This is a typical floor plan that I've just developed, right? So this is a single story residential building, like it is something around 30 feet by 38 feet. And it has got a lot of things like the basic stuffs like the living room. I'll zoom a bit so you'll understand much better. So this is the entrance, the portico, and this is the road, and this is the staircase. It's a single story, so just like a single building. And then this are toilets, baths, and workshop room, then study room on the other side. And in the other side, it's a kitchen, storeroom, and a master bedroom kind of thing. Right. So, and then living room and the dining room or something like that, right? And we have got doors and different types of doors and different types of windows, ventilators, and so on. And also, we have basically got all the furniture items and all, like it's something like a block or something like that. So we'll just insert it in this diagram, right? And then we have got different dimensions for each. Say, for example, W2 window is 4 feet by 4 feet, whereas W1 window, which is the main window, which is something, 6 feet by 4. And we have different types of doors, the doors for the main rooms and doors for the smaller rooms or the auxiliary rooms. And then bath and toilet, we have got different doors. Right, so this is typically the floor plan. We're gonna try to simulate planning for construction of this particular single story residential building. Right, so this is a given floor plan. This is the overall floor plan, which is something quite simple for us to understand and to accelerate our memory on different processes, as well as to see what could be the initial activity or what could be the intermediate activity and what could be the final activity and something like that, right? So a lot of activities are required or tasks are required to construct this particular single story residential building, right? Right. So I've also done a 3D BIM model. So BIM stands for Building Information Modeling. So this is the architectural model. So 2D may not give you a feel of how the building looks like in a realistic, but if you draw a 2D elevation, but even then it's just a two-dimensional view. But in a 3D, that gives you more clear depth. There's a measure called depth in engineering, which is high. It's just very important than height and width. So this is the depth. This gives us a quick overview of how the building will be if it is built, actually. It has got staircase, it has got windows, and it has got, the architectural columns. This is all structural columns, so architectural columns, and a balcony, and then parapet walls, water tank. This is something like we can take it as a precast water tank, right? So we can even replace it by the plastic tanks or something like that, PVC tanks. And then you can see the floor materials, like this is kind of a tiles or a marble, or it can be anything, mosaic or something. And then the walls are concrete and something like that, right? And you can see the drain pipe from the internal plumbing units, or especially the toilets and something like that. So that gets drained. So anything that is below this is what we call a substructure. Right? So there's a plinth beam comes here, and beneath whatever it is, as we call a substructure, and this is a floor level, and anything that happens above that is called superstructure, right? So that's only two things, one called substructure and superstructure. So we'll be looking into each and every component in much detail, but this is just a 3D architecture model. But in building information modeling, there is a term called wireframe. So computers generally very sophisticated in terms of generating wireframe. So why we are really interested in looking into the wireframe is this is just a solid element, like it looks like pretty solid, but we can't able to see what happens inside. Like say, for example, if you are planning for a mechanical elements or plumbing elements, or even electrical elements, say for example a fan. So we know that living room is somewhere here, but how do we provide fan in that living room? So for that we need to do something called a wireframe modeling, right? So wireframe modeling is making this a little transparent, or the transparency is like the level of transparency we required, we can keep it like that. And then this is the wireframe mode. So that's the same building. We amassed all the architectural elements, and this is an MEP model. So MEP stands for mechanical, electrical, and plumbing. Right. You can see the plumbing line comes from the water tank, and it gets distributed to different portions like the toilet, water closet, and again you can see the sink in the kitchen. You can zoom a little bit so you can understand it much better. So this is a sink in the kitchen, so you can see the distribution of water lines. So it has to comes from the water tank. And then the fan and the other electrical fixations, you can have this in the particular, units or something like that, right? So this is a combined model. So since it's a residential building, we may not have something called a duct works, like in case of a mechanical work, but we do have electrical and plumbing work, something an MEP model, right? So this is how we generally do a pre-construction visualization. So why this is pretty much important is this will give us a conceptual framework for planning or effective planning. There's a saying, right? So you can fail after planning, but you cannot fail for planning or something like that, or you should not fail in planning. So that's meaning that you cannot afford to miss planning in your project management strategy, right? But you can fail even after planning because that planning may not be efficient or effective. But then you cannot fail from planning. Like you have to plan your activity. So that's what basically the first functions of management is planning, right? So this gives us an idea of the number of water closet and the running meters of the plumbing lines and the electric lines. And not only that, we also can see what are the different elements, the height and the width and the depth, so that you can estimate the quantities like the earthwork, how much the earthwork you have to do, or how much is the concrete you can optimize, not use, but optimize. Like for example, if you make this as a precast, you see that purposely I made this is cast in situ and precast. I hope you now know the difference between a precast and a cast in situ. Precast is manufactured at factory and assembled at site, whereas cast in situ or concrete gets poured in the first stage and then it gets hardened by a process called curing or something like that, right? So that's the basic difference, right? So you can find out like, or you can even replace this by PVC tank. So all these things can be done in the pre-construction stage, but only by visualization. So that's what basically we call it in a normal sense called planning, right? So that's what we're gonna achieve in this particular class. So, right. So the first and foremost thing is planning, and say let's take a look at the construction planning. And the first step in the planning is the work breakdown structure. So work breakdown structure is the fragmentation of different activities. Like we have got a lot of activities that are required for constructing the single story residential building, but we need to fragment that. We need to order that. We need to put that based on the sequence or something like that. So that's what basically called a work breakdown structure. This is just like your preparation, exam preparation, in which you revise the hard portions very thoroughly, whereas the lighter portion where you have a good memory or good experience, you might revise some little lesser or something like that. So if you prepare for an exam, then you will be studying module wise, and the module which you like most or which you feel it's pretty good, you spend lesser time, whereas when you compare to the other module, so you rearrange the sequence based on the allocated time or available time, right? So that's what basically means a work breakdown structure. It is to fragment into pieces so as to give a clear picture of what to do in a different positions of time or something. Right. So WBS itself is not time framed. It's just like list of activities, whereas WBS plus time will become a schedule. So that will become the second function for management. So that will be take a look at the next lecture or something. Right. So these are the different work breakdown structure. You can take a look at this in much detail. So to accomplish the construction of a single story residential building, that the one I just showed you, first and foremost important thing is activity ID. Why do we need to codify the activities is that, right? So there are Humpty number of activities, right? So it'll be very difficult to, represent that in a Gantt chart that we will be developing in the next lecture, right? So for example, if you see a site clearance, it's a two-word, but if you take a look at this, transportation, excavated earth materials, and reinforcement, detailing, and fabrications are pretty good, pretty heavy letters, lengthier letters. So to represent in a diagram, it will be very difficult. And also sometimes you can see there's something called reinforcement, detailing, and fabrication, A07A. Then something called reinforcement, detail, and fabrication. This is A08A. Both are having the same text of reinforcement, detailing, and fabrication. But A07A represents that's under footing or foundation. So this is for foundation reinforcement, whereas this is for plinth beam reinforcement. So in order to have a variation, so or to have a clear-cut demarcation of A07 stands for foundation, whereas A08 stands for plinth beam. So we will be generally codify this, right? And there is a format available which is followed universally called master format. So that we will be discussing maybe the end of this particular module. But as of now, I've just given a code like A00. So if you have a multiple activities like 100 activities, you can even go for 3 zeros or something. Since I'm pretty sure that probably it will be less than 99 activities, so I just can represent that by A00. So A00 is a site clearance, which is kind of a preliminary work. So it is not an actual construction work, but it is mandatory. Without you clear the site, you cannot do an earthwork. Fine. When there are a lot of vegetations and a lot of other elements present in, you need to really clear the site, something like clear the non, contributing elements, like something like that. Then you can have to mark the site marking. Site marking is the central line marking. Probably you learn these terminologies in the quantity surveying, when which the central line of an element gets marked. So, which is central line is the midpoint of the element. Say, for example, so this is the the periphery of this, and it's a boundary. And to have a clear-cut understanding, I can go to the floor plan, right? So this is the floor plan. So this is the width of the this particular wall, and half the distance, which is the midpoint of this, gets marked. So that what happened is the foundation, half the foundation will be other side, and half the foundation will be other side. And then the wall, the center of the wall will give us an idea of how this wall can pop up something, right? So they generally mark the center line. And since we have not talked about any details of this foundation, it will be generally isolated footing, say this corner, this element, and here one, and here one, and all the place where the walls meets, where the load distribution is to the ground. So we'll provide the foundation. So all those things can be marked only if you have a central line marking, right? So once you do the central line marking, you can do earthwork excavation. So that typical quantity, the center line plus the equal distance, symmetrical distance, or sometimes there will be unsymmetrical footing also, but that's very much a disaster. But generally they provide it when they don't have space. Say, for example, the site is at the corner of already existing two buildings. In that case, they cannot have exactly half the center line. The reason is that if you provide, then the entire building can be small or shrink. So to accommodate that, they'll go for eccentric footing. They call eccentric footing, by increasing one dimension of the footing little bigger, whereas to accommodate the overturning moment and something like that, right? So those things you'll be learning during foundation engineering. But generally for this example, we take like we don't have any space constraint, so we'll look into the isolated footing, and that particular quantity gets excavated, like the definite width for it, breadth for it, and depth for it. So it could be a shallow foundation, right? So we don't look into really pile foundation for this. Say single story, say the hard stratum is really good, and then we go for the shallow foundation, specifically the RCC isolated footing, right? And then we talk about dewatering. Suppose the water table in a particular site may come up during particular month, or accidentally it might increase because of the precipitation during that particular period of time, or some disturbance in the ground water level, so it can pump up when you do an excavation. Then you have to go for a dewatering. So this is optional. You do it only when you require something like that. If you don't find it, if you don't have the waters rising up during your excavation, or your pits does not soak with water, then this process may be avoided, and this is just an optional point. And so soiling. Soiling is a process where in which you tamp the soil, or the underneath of the excavated soil, to give a hard stratum for the foundation, right? So if the foundation is laid on loose soil, it might get into settlement, or it could be just find a differential settlement. So when a foundation fails, it's a detrimental to the structure. So they generally provide tamping or make it very hard. Then they lay the PCC footing, which is the next step, right? So this is also an optional process. This depends upon the safe bearing capacity of a soil, right? So if the safe bearing capacity is very low, then we need to find another mechanism to enhance it, and that particular process is called soiling. They could add hard rock pieces to make it more solid, or they can go for compacting the existing rock, existing soil, to make it a hard stratum, or they can go for micropiles. Right, so there are different techniques they can use depending upon their requirement, and depending upon its significance. Right. The next is, once you excavated the earth materials, you might require some amount for refilling when you lay the footing. But mostly that gets those are can be called as construction debris that has to be removed out of sight, right? So for sustainability. So when you excavate an earth, it can be replaced to some environmental feature. Otherwise, it is not sustainable, right? So if it is dumped for waste, and that's not going to be useful, right? Something like that. And we need not 100 percentage, the earth which we have excavated. The reason is that once you remove, say for example, L beat, D volume of earth will get excavated. Once you pour a concrete, say RCC footing, some volume of that gets already filled by concrete, so you don't have to necessarily take the 100% earth and fill it there, but instead you can take 70% or 60% of the excavated earth, and you refill it on that particular surface, and that's how generally it is done. So transportation is also and very much important thing. And you can see all these things are preliminary works. So we don't really look into the detailed stuff. So these are just mandatory steps to lay the basic, foundation or the footing for the single story residential building. Then it is PCC laying for footing. Like this, PCC stands for paint, cement, concrete. So we'll be creating a bed for our concrete, the reinforced concrete foundation, right? So just like making, even though we perform soiling, making the hard surface, making the bottom of the earth pit very hard. But in addition to that, we'll generally pour PCC, which is plain cement concrete, for further rigidity of the reinforcement, right? So something. And then A07 is like RCC footing construction. This is also very much important. The reason is that, like, once you lay the PCC, we'll be generally, fabricating, you can even take it as a parallel activity. During PCC laying itself, people start preparing reinforcement for the, footing or foundation, right? So once the PCC gets, hardened, there isn't any wastage of time. So they generally bring the, assembled reinforcement, and then they place it, and then they provide formwork. The formwork is a temporary structure that gives the shape of the concrete, right? So people call this as to be a shuttering also in a colloquial term. That formwork is the actual term. And other materials like accessories to formwork, or generally, the scaffolding and other elements are called false work. So that's the two difference that you should know. Probably you would have learned that during construction materials and technology course, but I just repeat. So formwork is the temporary structure. It could be made of timber, steel, aluminum, and so on. Whereas a false work or scaffolding, like hook block scaffolding, access scaffolding, so for finishing works and something like that, right? And then once formwork is erected, we already placed the reinforcement before, mocking up the, formwork. And then once that is done, then concrete is poured into the mold, which is the formwork. Then the concrete with the, reinforcement already placed will act as a composite member, and that is typically the reinforcement concrete. Right? So this is the process by which you can perform the reinforcement, RCC footing construction. Right. So once that is done, then we will be, removing the formwork, which is called a de-shuttering. There's a definite period for a de-shuttering for different elements, like foundation have got different days, like beams, columns, slabs have different days. And generally slabs, you might have seen in construction site, slabs, they don't remove the formwork, even though it can be removed in 7 days to 14 days. But generally people will keep the plumb, which is the prop or the shore, for some regions where the critical load acts. So they only remove some 50% or 75%. The remaining thing, they will just keep it for some additional period of time. Right. So those include partial de-shuttering or something like that. So probably you will know when you do internship or something like that. Then once the de-shuttering is done, we need to cure the fluting. The curing is a very important thing. So concrete release excess energy and heat during its hydration process. So in order to convert the fresh state into a hardened state, we'll wait for the stripping time. After that, we will just remove the stripping, the formwork. Then it will be allowed to cure for some period of time until it becomes completely solid, right? Solid masses in there. So that's what basically curing. So all these things are called subtasks. Remember, A07 is a main task, which is the construction of foundation, RCC foundation. Whereas A07A, 07B, 07C, 07D, all these things are subtasks, right? So that's why I just made it in italics. All these things are subtasks. In order to, all these 5 subtasks are required to do this particular main task, or this is main heading, this is kind of a subheading or something like that. Whereas that same process is repeated for RCC plinth beam. You need to do a reinforcement, formwork, concrete manufacturing and pouring, then de-shuttering and curing, right? And then earth and soil filling. So once the substructure, the footing and the plinth beam is done, generally the voids, we would have taken extra width only during excavation. So once the member is constructed, then we will do a backfilling or refilling of the soil or something like that, right? Or the excavated earth gets replaced with the voids available in the footing and as well as in the substructure, right? Then we look into the sand filling and then flooring, compacting the soil beneath and also within the plinth beam. And then we'll just do a flooring, which is the hard stratum. And it could be a cement concrete flooring or any other types of flooring, but generally it is slab, which is at the bottom, right? So to have a rigidity or to have a plain surface. So that's how it is generally done. So all these things can be put under superstructure or substructure work. And the next step is the superstructure work, so which is anything that beyond the ground level. So underneath the ground level, we'll consider to be a superstructure, substructure, I beg your pardon. And anything above the top is called superstructure. And sometimes if you have a basement, so basement is also a structural entity that can be rather given as a, it will be given as a substructure than a superstructure, even though it has got all the elements like in the case of superstructure, but we will be generally considering that to be a substructure, something like that. And the retaining walls underneath and so many other factors are responsible or to design that particular element. So we, since to avoid complexity and for beginner level course, so we will be restricting our idea with the simple structure rather than the complex structure. Then it is superstructure. We'll be looking into the RCC column construction and the same process, same subtasks like reinforcement, formwork, concreting, de-shuttering, and curing. And so as the beam construction, band will be looking into the reinforcement, formwork, concreting, de-shuttering, and curing. Right. Next, pretty much important is the slab, which is the final framework in the frame structure. Say first we laid the plinth beam, then on the plinth beam we'll raise the columns, and once the columns is ready, we'll be going with the beams and slabs together, right? Sometimes beams are casted ahead of slab. Some generally it is both constructed monolithically. Beams and slabs are generally considered monolithically. That's something like that. They generally cast it at a single point of time. Right. So maybe in the next class, I'll show you some pictures on the construction site so you can understand much better. Right. And then the slabs are same procedure. We talked about reinforcement, formwork, then concrete manufacturing, then unpouring and de-shuttering and curing. Remember the de-shuttering time for slab, column, and the foundation are not same. It's unique for unique operations. Like slab has the highest numbers of days. After that, only you have to de-shutter it or something else. So slab is considered to be the horizontal element, whereas even beams and columns, beams can be called as horizontal member, but it is not as comprehensive as a slab, because beams are framed like stick elements, whereas slabs are plate elements. So there's a huge difference between that. So if a plate element fails, it's a detrimental to the structure. But if the beam element fails, they can do by removing a particular portion, and then they have to re-strengthen them or something like that. But slab failure can create a havoc or something like that. But generally, it is constructed monolithically, and extra time is given for the de-shuttering and curing something. And then the other elements like portico, ramp construction. Since we don't have ramp here, but we can call some steps from the ground level to the portico or something like that. Right. And then the same procedure like reinforcement, formwork fabrication, then concrete manufacturing and de-shuttering and curing. And then staircase. So staircase here in this diagram, we had given that as an external member. Sometimes if you have a staircase inside also, you can have a spiral staircase, a steel staircase, whatever it might be. So in this case, since it is the external one, so we don't have something called a landing room or something like that. But if you provide it in interior, then you have to provide a landing room, the shed kind of thing. So that's the planning thing that you should really do. But I just wanted to keep a very simple RCC. It is not dog-legged staircase, but it's something like a bifurcated staircase, semi-bifurcated staircase. Right. So once the staircase is done, which is very important element, is the fixing balusters, banisters, and handrails. So before that, like once the staircase is done, then we'll go for masonry, like brickwork, then filling the parapet wall, and balusters, banisters, and handrails. Let me explain you what is balusters, banisters, and handrails. Say these things, since I just made everything as a glass and banister, balusters are generally the ceramic or thing, or it could be the concrete thing where you can see in the balconies like some bulged kind of elements, no, individual bulbs. So this is called balusters. Banisters are the steel members, steel structural elements, when which it will hold the handrails. So that's those things called banisters. Right? So once the brickwork is done, then they'll go for this, and then they go for painting, plastering, and whatever might be. So up to this thing, the superstructure is gonna be over. So once that is done, then we'll go for MEP, installing the mechanical, electrical, and plumbing works. Then we talk about precast water storage tank, then bring it to the site and assemble it at the top. So up to this, the superstructure work gets complete. So once that is done, once the superstructure was done, then you can look into the finishing work. Or if people sometimes they refer this to as a final work, right? So they lay tiles, marble, stones in the interior building, and they go for plastering, interior plastering as well as exterior plastering. And then once the plastering is done, they go for this whitewashing and then painting or something like that. So all these things can be put under painting. So internal painting and external painting. So sometimes the architect's involvement in painting is also nowadays can be very evident. Say interior decorators, the exterior paints or something like that. So painting is also important aspects nowadays, not only in terms of colors and textures, but also in terms of weatherproofing and something like that, right? So this is kind of a very important thing. Right? So this is the final activity you can call, but there are other activities like handing over process or repair of minor works or something like that. So that's all not major works, or this are the 23 are the major works. And you can see 62 activities. Out of that, I think 2 is optional. 60 activities are required to complete this particular task, which is the construction of a single story residential building. We have just put down the list of activities or major activities that are required to construct. So this is typically a work breakdown structure. So this is typically a work breakdown structure. But in the next thing, which is the construction scheduling, we'll be looking into the addition of durations to this, right? So this is just an abstract idea or just list of activities or like to-do list if you prepare every day, list of activities that you plan to do. But when you add a time frame to it, then it will become a schedule rather than it will be a to-do list or something like that, right? So this is typically the schedule. Like I'm just going to show you. Like this is the construction scheduling, which is the second functions of management. Say for a site clearance, I may take 1 day. Here I represent in terms of day, but I need to tell you that this is an not 24 hours. This is 8-hour duration per day. Say 9 to 5 or 8 to 5. So if you depending upon that, if you so in the next class we'll be looking into the calendar days and time and official work time, holidays, and other aspects of scheduling. But let's focus on the preliminary schedule today. Like for a site clearance, I give it 1 day. All these things are a main task, right? Say dewatering and soiling, I take 8 hours. Whereas transporting excavated earth, I just require only half a day, which is 8 divided by 2 is 4 hours. I may require a maximum of 4 hours, like transportation from excavated earth to other or landfill or something like that. Then PCC laying, this is the main task. I require 2 days time. This is generally calculated or estimated based on this particular site. So based on this particular site, I might require laying of PCC footing in 2 days, like 16 hours. I can lay 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, something like 14 to 16 footing. I will be requiring just 2 days of 16 hours, right? So this is just like, laying only. It is not curing, right? So curing takes time. So that will be after, laying, you leave it for 24 hours or 48 hours or depending upon that, right? So next is the main head, which is called footing construction or foundation construction. That requires 14 days or 2 weeks time, right? So the sub task, how do we estimate this to be 14 is that the sub task. Reinforcement detailing and fabrication takes a day. Formwork fabrication and setup takes a day, like half a day for fabrication, half a day for setup. And then concrete manufacturing and pouring takes a day. And de-shuttering, this is very important. Like the time taken to de-shutter is 4 days. Once you casted today, only after 4th day you will be de-shuttering that. individual thing. Then after that, you need to wait 7 days till it becomes completely solid, or the process is called curing. So fourth to seventh day is a curing day, right? Or something like that. So totally four plus seven. It's not 4 to 7. 4 plus 7, right? So that is why it is 14 days, right? Something like that. So we'll be looking into the sequencing of these tasks in the subsequent lectures. But as of now, understand these are pretty much an important element, which is adding time frame to our work breakdown structure. And then the process continues and something like that, and we have got fully done. And what is the project duration? So far I've given individual activities, right? So far I've given individual activities. What is the duration of this project? Normally, people make a mistake that they'll calculate all these things, they'll sum up all these things, and they say come up with a rough figure. So that's pretty wrong. The reason is that so you cannot do a site marking when the site is not cleared. So there's a dependency. You can only do a site marking once the site clearance is done. But whereas once the masonry construction is done, before parapet wall, you can perform electrical plumbing work. So you don't have to really wait till this finishes, right? Just till the parapet wall or fixing a baluster finishes. So you can even do it after this itself. Or sometimes all the three parapet wall fixing, baluster fixing, and MEP works can be done parallelly, right? So that's how it is generally done. So in that case, then this say for example masonry wall, after it gets constructed, we have got 2 days, 2 days, and 7 days. So within 7 days, you can perform. The 7 is the highest. So within 7 days, you can perform all these works, right? Within a week, you can perform not only plumbing works, not only electrical works, but also fixing the balusters, banisters, and handrail, and construction of the parapet wall, right? So that's a big masonry work only, parapet wall, something like that. Parapet wall is the topmost region, right? So for safety measures, we will keep this boundary walls at the top, which is like 1/4 of the original wall, or sometimes it is a 1 meter, or sometimes 900 mm. So depending upon your requirement, you will just keep this particular. But if you go to any bigger construction, high-rise building, they generally raise it to at least half the wall or something like that, right? Or at least three, fourth of a wall or something like that. So for fall protection and other aspects, but above that they can have glass frames for viewing, something like that, right? So it depends on sometimes architects decides that based on the human factors. Like the average height of an Indian may not be 6 feet, but less than that. So, but if you go for European countries, the average height may be 6 feet. So in that case, depending upon the place, something like that, they can decide the height and something like that. So it's one thing is for safety, another is for aesthetic. Suppose you provide it very high and you don't have any view from your corridor, then nobody's gonna buy the apartment, particular apartment or high story building. Right? So it's, safety is also important, but also aesthetics and other factors are important. That's why the role of architects plays a huge role in the many projects, construction projects. Right. So let's go. Once this is done, it's pretty much obvious that we have got our days, which we will be looking into the linking of activities. Then only we can find the project duration, not by adding up all the duration. And final concept that we're gonna talk about today is the trades, different trades in construction. Have you heard the term like trades in construction? It's a very famous term. Generally, the senior level managers and others refer this as a trade rather than it's a unit or some category or something. Right. Say, what are the different people? We talked about activities, but what are the different people involved in the construction of this particular single story building? Right. The first is the quantity surveyor, maybe an office job by the management or by the people in the office or something like administration management or something. Then budget and finance, cost auditing, cost accounting, and cost sheet preparation. All these things are done by the finance department in the management, or something like quantity survey, under the quantity survey, procurement or something like that. Then architects are required for preparing the architectural drawing. So the first thing, the second drawing I showed was this architectural drawing. So this is pretty much an architectural column. They can modify this, or they can change the layout with the different elevation, and they can have differential views or something like that. This is one such view. What happens if I want to see the other view? This is just a wireframe, but it's another view, right? So something like that. So all these models are prepared by architects with the vegetations nearby. They can have a trees, like boundary walls and roads and other aspects they can prepare, so that give you a realistic understanding. And then very much, yeah, here it is. Then we talk about engineers, where structural engineers, designers, and draftsmen and detailing also a job. Earlier, draftsmen used to prepare structural detailing also, but now people in bigger companies, they rule out that only engineers prepare detailing and drafting. And but with the help of draftsmen, they develop the drafting or a layout plan or something like that. Right? That's why I put under engineering. And surveyors, this is not quantity surveying. This is the surveying of the land or the site. Generally, it is the construction trade, and earthwork operators also construction trade. Bar benders and reinforcement assemblers also construction. Concrete manufacturers construction. And carpentry, they can be in construction. Masons and masons for masonry work and plastering, and they'll be under construction. Electrician, plumbers, or comes under MEP. They can also be clubbed under construction, but mechanical, electrical, plumbing is a different trade. So it will be good if skilled electricians are taken, and that they can be categorized under mechanical, electrical, plumbing. Then painters in construction, steel fabricators for handrails and banisters, then precast concrete manufacturer. You can call this as construction, or if you want to bring a precast unit from a factory to a site, then you can look into this under transportation. But even then, that comes under construction. Sorry, construction. Right? Then fabricating doors and windows or carpenters, they can be under construction. Glass manufacturers for windows and ventilators. It's not manufacturers, they make the definite shaped glass and tint glass and textures uh, to accommodate into the ventilators and other windows or something. Even steel grills are required. Or we need blacksmith to make up the steel grills or something like that. So everything you can put under construction, and interior decorators you can put under architects or something. Right, so these are the different peoples are required for the completion of this single story residential building. But I've just put down the list. This is just like another work breakdown structure for the resources or human resource. But we need to estimate not time, but the number of people. So number of people will be comes under staffing, which is the third functions of management. So that we'll be seeing in the subsequent lectures. Right. All right, so this completes the end of today's lecture.